Hello everyone, I'm Mehmet Bozdal, researcher at Abdullah Gül University. Today I'm going to talk about my research, Security of In-Vehicle Communication, as a part of second Open Research Knowledge Graph Curation Grant. First, I will give you a brief introduction about my research. The vehicles are getting more electronic and more connected each day. This is a shift underlying electronic control units, ECUs. ECUs are distributed all around the vehicle and control one or more function of the vehicle like light, powertrain, and infotainment system. Each ECU communicate with each other via in-vehicle communication protocol, and CAN bus control area network is most widely used in-vehicle communication protocol. As you can see in figure 1, CAN bus is represented as two wire CAN high and CAN low. Each node is attached to this network, therefore it is easy to maintain. The CAN bus is message-based communication protocol. Each CAN message has a priority bit, which is in the message identifier field, provide priority access to the CAN network. The CAN protocol is also relatively cheap to the other protocols. Therefore, it is mainly used in automotive industry. However, the protocol is designed in early 1980s. Therefore, it is vulnerable to attack as there is no security mechanism like encryption and authentication. As you can see on the photo, the vehicle is hijacked remotely. Its braking system is disabled. To prevent these attacks, there are some research ongoing on. These research can be categorized as network segmentation, encryption, authentication, and intrusion detection system. Network segmentation is splitting to network in sub-networks. Therefore, the critical network is isolated from the user accessible one. This is already exists in commercial vehicles. However, it's alone cannot provide the security. Encryption and authentication is another method to secure CAN network. Encryption is scrambling the data. Therefore, it will be harder to understand messages, therefore implement the attacks. Authentication only allows the verified user to access the bus. However, encryption and authentication requires some processing power, and current electronic control units is not suitable to overcome these overhead. Intrusion detection systems are proposed to mitigate this situation. Intrusion detection system basically monitor the bus, and if there's a deviation from the normal behavior, it generates an alert. How we can evaluate the intrusion detection system is, if we assume we have a binary classifier, there are 4 possible options like true positive, false negative, and true negative. If we have a malicious message and our IDS identified that message as a malicious, it's true positive. If we have an authentic message and identified it as an authentic, it's true negative. On the other hand, if we have a malicious message and we identified it as a non-malicious, it is false negative. And if we have an authentic message and identified it as a malicious, it is false positive. Traditional accuracy is used to measure the performance of the intrusion detection system. However, accuracy alone is not give information about how successful that ID is, particularly if data is not symmetrical. Therefore, we also need sensitivity, false positive rate, and precision with these true positive and false positive numbers. I will give some example how open research knowledge graph make things easy for comparing the research on security. This is the first comparison. It compares the CAN bus intrusion detection papers, it has 12 contributions. The comparison provides information about which method is applied on which data set by using which parameters. It also presents the result for intrusion detection system. The Open Research Knowledge Graph provides us the table with essential information about those papers. For example, with the data set, I can use some keywords and then filter, and then the relevant papers appears. So with these, now I have only 2 papers which has the deep keywords, and I can compare these papers. They both of them has the same data set actually. And when I click the result, so those attack performance metrics, so I can see the result for the first paper, and accuracy is 99.97 and sensitivity is 100. And then I can click for the second one and see the result for the second one. And I can understand first method is better than the second one. And it is easily, you can look at the essential information for algorithm names. The first one is using the deep convolution neural networks. On the other hand, second one is using the wavelet analysis. So if we look at the data, for example, this one has the 2 data set, car hacking data set, and in-vehicle intrusion detection using deep convolution neural network, the same reference to the same paper. So if we look at, if we click on this data set, we will have the URL of that data set, and we can easily click to data set and go to the web page and get all the information about the data set. This is also the same template can be used also for the other intrusion detection system. For example, here, instead of the control area network, we have another contribution comparison related to intrusion detection system for water treatment and distribution for smart cities. Here we have a similar architecture. We have the data set. We can understand that all of the paper are using the secure water treatment dataset, and when we click dataset, we will have the information and URL about that dataset. And the methods, we can easily see which methods are used in these datasets and get the results for which paper we want. So it is basically has all essential information about the papers, and we can also filter those information and process them according to our needs. Here is another example. It shows the authentication. It's about authentication of CAN communication. Here is structure is a bit different, but the working principles are the same. We have the description of the papers and which method they have used and what are the essential parameters for the authentication, like do they use a key, which keys, and is there a session, or is it backward compatibility for the CAN bonds, or do they implement it on real life or not? So it is very easy to compare to papers if all the fields are filled. For example, with CAN, centralized authentication system CAN, we can see that they use SHA-256 and they use a symmetric key. And this authentication method is sessionless and it is not backward compatible. They implemented their method on FPGAs. We only have essential information here. So when we are comparing papers, this saves a lot of time.